Okay, we're going to do a problem about the second law of Newton, second law of Newton. And it's going to be about two-body system. It's going to be two-body system. Okay, two-body system. So what do we have here? Okay, so we have like a little table, something like that. It comes this way. And you have your floor right here. Okay. And let me make this one a little better here. Okay. Yeah, it has to kind of look horizontal. There we go. Well, more or less. So what do we have here? We have a particle. We have a particle. We have a particle over here. And we have a pulley right here. This is your pulley right here. Let's fix our pulley here. So we're gonna have a pulley right here. Okay, and then we have a little cord here, and we have another cord that comes this way, and we have another particle hanging from the cord. Let's call this M2, and let's call this M1. Okay, and this is a surface, and this is another surface right here. I mean, this is a height. This is a height. This is a surface over here. This is the floor, and it's moving this way. It's moving this way to the right. The system is moving to the right. So let's say that mass 1 is 6 kilograms. Mass 2 is going to be 4 kilograms. 4 kilograms. Okay, you got 4 kilograms right here. And you're going to have the coefficient of kinetic friction. The coefficient of kinetic friction is going to be 0.5. It has no units. And you want to calculate the acceleration. What is the acceleration of this system? And you want to calculate what is the tension. You want to calculate the tension and the acceleration. So how do we solve this problem? Well, let's go for one first. And we have two particles. Particle 1, particle 2. So let's go with particle 1. So we can do a body diagram for particle 1. And this is for the first object. So we have a force this way, which is the force of the force on the surface, which is the normal force. Then we have friction that goes this way. So we have friction. There's friction here. Okay, and then we have the weight, which is going to be M1G. And then we have the tension that goes this way. So you got the tension right there. And this system is moving. So it's moving to the right. So the summation of the forces, let's get the summation. The summation of the forces in the x direction is going to be equal to the tension minus the friction. And that's going to be equal to the mass 1, acceleration 1. Okay. And the summation of the forces in the y direction is going to be equal to the normal force minus m1g, and this is going to be equate to 0 because there's no acceleration in the y direction for particle 1. So for the first particle, there is no acceleration in the y direction. All the acceleration is in the x direction over here. And the friction is going to be equal to mu k, which is the coefficient of kinetic friction, times the normal force. So we have, let's say, three equations right here for the motion of the particle number one. And we can say that from this equation right here, this one, number two, equation number two, we can say that N is going to be equal to M1G. And we can substitute this in the equation number three. So the friction is going to be mu K, which is the coefficient of kinetic friction, times N, but N is going to be M1G. And there you go. You got your friction, and then you go back and you can plug it in the first equation and this equation over here. So let's do it here. So we have the tension minus the friction, which is mu K M1G, okay, mu K M1G. It's equal to mass 1, acceleration 1 in the x direction. And you can solve for the tension. So the tension is going to be mass 1, acceleration 1 in the x direction, plus mu K M1G. And we're going to leave it right here for now. So let's go to the second system. This is for one. This is for system one. And let's go to the second one and let's do a body diagram of that. So we'll do it over here. We'll do it for number two. This is particle number two. And for particle number two, we have our body diagram right here. And what do we have? Well, we have the tension that goes up. So let's call it tension right here. Tension go up. And we have the weight, which is M2G, and that's all we have. So for this one, we have that the summation of the forces in the y direction is equal to, well, this is coming down. So remember that we have gravity pulling down. Gravity is pulling this way, minus g. And it's going in the direction of the acceleration because the acceleration is downward. The acceleration is the acceleration of gravity. And the acceleration is going down. It's going to be minus g. But M2G, which is the weight, is a vector that's in the same direction of the acceleration. So it's going to be positive. So it's going to be M2G minus the tension, and that's going to be equal to M2 acceleration 2 in the y direction. So we can solve for the tension. So M2G minus M2 acceleration of the second particle in the y direction is going to be equal to the tension. But that's equal to this one over here, which is M1 acceleration 1 in the x direction, plus mu k, which is the coefficient of kinetic friction, mass 1g. And we can solve for acceleration because acceleration of the particle 2 in the y direction is going to be equal to the acceleration of particle 1 in the x direction, and that's going to be equal to the total acceleration. So you got this relation right here. And we can take advantage of that relation because the acceleration is going to be the same for everybody. It's going to be the same acceleration. So what do we have here? We have mass 2g minus mu k, which is coefficient of kinetic friction, m1g is equal to mass 1 acceleration plus mass 2 acceleration. And we can factorize the G. So it's going to be M2 minus mu K M1, and that's equal to acceleration, and we can factorize mass 1 plus mass 2. So we got that G, and then we got that mass 2 minus mu K mass 1, and we can divide all this by M1 plus M2, and that's going to give us the acceleration. So let's plug in values. So it's going to be 9.8 meters per second square. That multiplies mass 2. Mass 2 is 4 kilograms minus mu K. Mu K is going to be 0.5. And that's going to be multiplying. This is going to be multiplying M1. M1 is 6 kilograms. We close parentheses. And this is going to be divided by M1, which is 6 kilograms, plus M2, which is 4 kilograms. And if we do all this math, we're going to get our acceleration. So our acceleration is going to be, if we do all that math right there, acceleration is going to be 0.98 meters over second square. And you got your acceleration right here. It's 0.98 meters over second square. Okay. And now we can get the tension. So we can go to either equation, which everyone looks easier to get the tension. So let's plug it over here. Let me get some space here. Well, we got the acceleration. So the acceleration is going to be 0.98 meters per second square. And now we can get our tension, and we can use any equation here of these. Let me see which one is easier. This one here says, okay, so the tension is going to be mass 2 acceleration, which we already know. Okay. So it's going to be that. We can do this one. Okay, we can do this. Let's do it a little better here. So the tension is going to be equal to mass 2g. Mass 2g, I'm using this equation right here. I'm using this one right here with this one over here. So it's going to be m2g minus m2 acceleration, which we already know. And we know that mass 2 is 4 kilograms. 4 kilograms. And this is acceleration right here. 4 kilograms times 9.8 meters per second square. And that's minus M2 again, which is 4 kilograms. Times acceleration, which we know that is 0.98 meters over second square. And if we do all this math, we know that Okay, let me put a sign here, a better looking equal sign. So this is going to be equal to this. And if we do all this math, we're going to get our tension, and our tension is going to be around 36 newtons. And there you go. You have a problem where do you have two systems? Two particles in the system, and they're moving with the same acceleration, and particle one has friction involved, and particle two is hanging, and you have calculated the acceleration and the tension for this two-body system using the second law of Newton, which is for particles that are in motion. Thank you, and we will do more problems later. Bye.